Resistance is a restriction to the flow of electrons in a circuit. The wire which carries the electrons will naturally have some resistance. The longer the wire, the greater the resistance. The thicker the wire, the lower the resistance. Resistance to the flow of electrons is different for each material, and the temperature of the material can also change the resistance to the flow of electrons. Electrical circuits use specially designed components known as resistors to purposely restrict the flow of electrons. This is either to protect other components from too many electrons flowing through it, or it can also be used to create light and heat, such as in an incandescent light bulb. Resistance occurs when electrons collide with atoms. The amount of collisions is different from one material to another. Copper has a very low collision rate, but other materials such as iron will have much more collisions. When collisions occur, the atoms generate heat, and at a certain temperature the material will then start to produce light as well as heat, which is how the incandescent lamps work. When a wire is wrapped in a coil, it will generate a magnetic field as the current passes through it. The cable will naturally create an electromagnetic field by itself, it's just intensified by the coil. By wrapping it in a coil, the magnetic field becomes so strong that the magnetic field starts to actually affect the electrons within the wire. But we'll look at why this occurs in a future, more advanced video. We can increase the strength of the magnetic field simply by wrapping the coils around an iron core. We can also increase the number of turns within the coils, and also we can increase the amount of current passing through the circuit. Now this is how electromagnets work, and it's also the basis of how induction motors work. If you want to learn more about induction motors, we've already covered this in another video already, just see the link on screen now. Now when a magnetic field passes across a coil of wire, it will induce a voltage in that wire caused by an induced electromotive force which is pushing the electrons in a certain direction. If the wire is connected in a circuit, then this electromotive force will cause a current to flow. This is the basis of how AC generators work, and the electricity at your wall sockets within your home is produced in a very similar way. Transformer. Now we can combine all of the aspects together that we've just covered, and when we do so we'll see that we can use one coil to generate electricity, and then we can place two other coils in very close proximity to each other but not touching, and this will create a transformer. The transformer will induce a voltage from the first or the primary coil over into the secondary coil, and this will force electrons to flow if the coil in the secondary side has a closed circuit. Now what's important about the transformer is that we can increase or decrease the voltage between the primary and the secondary coils simply by changing the amount of coils on either side. Again, this is a subject all by itself, so we'll cover this in a more advanced video later on. Now something else which I just want to briefly mention is the capacitor. So a capacitor forces positive and negative charges to separate across two plates when it is connected to a power supply. This causes a build-up or store of electrons within an electric field. When the power supply is cut or interrupted, these charges will then be released, flow up and meet again. This provides a power source, but only for a few seconds until the charges have paired back up again. It's slightly similar to a battery, but capacitors are very common and they're in almost every single circuit board. We'll cover this obviously in more detail in a future video, just be aware of these. So the last part I want to cover in this video is that there are two types of current electricity, that being alternating current or AC, and then direct current or DC. Alternating current simply means that the current flows backwards and forwards in a circuit as the terminals are constantly reversed. This is a bit like the tide of the sea. It goes in and out, in and out, in and out, so that it's reversing constantly. Now alternating current is the most common source of power, and the plug sockets in your homes and your buildings and schools and workplace, etc. These will all be providing alternating current, AC. Now on the other hand, we've got direct current or DC, and that simply means that the current flows directly in only one direction. It does not alternate. This is what's provided from batteries, and almost all your handheld devices are from this as well. So we can convert AC to DC and vice versa using power electronics, and this is how we charge and power small devices, and it's also how solar panels can be used to power our homes, because solar panels produce DC power and our homes need AC power, so we have to convert this for it to be usable. So both AC and DC have pros and cons to it, but for sure we'll look at this in another later video. It's a bit more advanced, and there's also quite an interesting history behind why we use AC and DC and the inventors behind that. If you've got 10 minutes, I definitely recommend having a Google or a YouTube of this too. Alright, that's it for this video. Thank you very much for watching. I hope you enjoyed this and it helped you. If you have any questions, please leave me in the comment section below. Also, don't forget to subscribe and check out our website, theengineeringmindset.com.